My name is Anna. I work for a startup within an advertising and marketing conglomerate, and I lead their innovation lab. So as part of our innovation lab, I get to play with all the cool technology and build basically software. So today I want to share with things that we've been working on for the past couple of years, and that's the exciting field of computer vision technology. So I have not done an ignition talk before, so let's see how good I'm going to be with my timing. Vision. Out of all our 5 senses, vision is probably the most special to us. That's how we perceive 80% of the world. That's the sense that probably can alert us about the upcoming danger. This is how we acquire information. But before we give ourselves a pat on the back, let's consider things that are out of our sight, things that are far away, or things that right underneath our nose. You can say, fine, we can be good at everything. You can't really see everything, but we're really good at seeing our immediate environment, so things that surround us. True. The problem is that recent advances in technology have exponentially increased amounts of information. The amount of images and videos and all the other visual techniques that we produce is overwhelming and humanly impossible to comprehend. So the same way we came up with ways to deal with faraway stars and close atoms, we came up with a way to deal with overload of visual imagery. And that's algorithm. Meet computer vision. It goes under names such as big data, deep learning, AI, and next year it's probably going to be something else. But the concept remains the same. We trained algorithms to understand a certain structure and understand how objects appear to be. And the opportunities around computer vision are incredible. Imagine a camera that tells you how long is a line at Shake Shack. Imagine if a TV set tells you if your kids are at home. And this is an example of how computer vision started. It started very simply. We tried to draw boxes around objects, and we could see if it's a human or not, if it's an animal or not. And the recent iterations also allowed us to see now what's inside those boxes. Is it a cat or a dog? If it's what kind of human it is. The latest, since there are lots of people working on computer vision technology, latest iteration allows us to distinguish between different breeds of dogs. And Google has an algorithm which is called TensorFlow, and it can even tell you how long are the hair on the body of the dog. And if you're still not impressed by this, how about this? We can tell right now facial recognition, emotional state, and we can tell you even the location where image takes place with longitude and latitude data around this image. It might seem like magic, but the way computer vision works is pretty much like school. Same way you teach kids, here to animals, tell me the difference. That's how you teach computers. You show it a bunch of images and you hope that computer is going to learn and understand what is the difference between the objects. And it's all thanks to this project. It's called ImageNet. It came to life in 2009, and what ImageNet was, it was just a bunch of imagery assets tagged by humans through crowdsourcing. And it's basically speed up the development of our deep learning algorithms right now, because now we had the data to fit it into the algorithm and work on the accuracy, on the performance, on the speed of processing. Any data scientist will give you the definition for machine learning as modeling abstract level data through passing the data sets through deep level graph, which consists of multi-processing layers with linear or nonlinear transformations. That's the definition. I prefer to think of it as a meat grinder. So you feed computer a lot of data, and it spits out a lot of data back. And the way it comes out is like this. This is data from computer vision. What you get back after you feed a lot of your precious JPEGs and MP3 files, you get a tag with a probability score of how confident machine is that it's seeing this image or not. And this is where human creativity really comes through. Because when I show to people those data sets, they're like, really? That's computer vision? That's what you're excited about? But you can do so many more exciting things with computer vision. And this really where the creativity is the limit. Think about this. When I show you an image like this. When I show you a lot of images of dogs, you go through and you're like, oh, a cute dog. Computer can help you deal with it so much faster because it's like a studious undergraduate student. It will go through the images and tell you what every breed of a dog is. So instead of thinking of computer vision as a friend or a foe, I propose to think of it as a tool, like a telescope or a microscope. And it's just a tool that can help us to see the world, more of the world, and to see it from a slightly different perspective. Thank you.